I am Parvez and welcome to my video on Python natural language processing. So in this video we're going to talk about different topics on NLP such as tokenization, parts of speech tagging, lemmatization, stemming, entity recognition, sentiment analysis, and different topics. So in this video we're going to use two libraries. We will use NLTK, Natural Language Toolkit, and also we're going to use text blob. So now first of all, what is NLP? So NLP, or natural language processing, is used for the interaction between natural language and also computer. It's one of the major components of artificial intelligence or AI, and also computational linguistics. There are different applications that you can use on natural language processing, and NLP is used everywhere, from search engines such as Google to voice interfaces such as Siri, and there are different other usages of NLP like spell checking, spam filtering, related keywords in search engines, knowledge base support, chatbots, machine translation, and also speech recognition, and many more. So now what's NLTK? NLTK, it's a natural language toolkit, and it's one of the best libraries for prototyping and also building natural language processing systems. Now if you check the documentation of NLTK, so this is the documentation of NLTK, and it is a leading platform for building Python programs to work with human language data. It provides easy to use interfaces to over 50 corpora and lexical resources such as WordNet, along with a suite of text processing libraries for classification, tokenization, stemming, tagging, parsing, and semantic reasoning. And there are different features that you can use from NLTK. Now for the installation of NLTK, so it's require Python 3.5, 6, 7, or 8, and you can just use pip install NLTK and it will be installed. And you can see that there are different for example, you can use for Mac, or you can use for Windows, and you can install according to their documentation. Also, you need to, after installation of the NLTK, pip install NLTK, you need to install the data for the NLTK. Now if you see installing NLTK data, NLTK comes with many corpora, Thai grammars, trained models, etc. A complete list is posted in here. You can check the list. To install the data, the first thing we need to install NLTK. So after installation of the NLTK, then we can use this import NLTK and NLTK.download. So now let me just show you. First we need to just import NLTK, and after that we can just say NLTK.download. So after that you will receive this kind of interface, NLTK downloader. Now you need to just click on all packages, and after that click on download. Now it will be download all packages. I've downloaded some of them, but I'm going to just click on this all packages, and after that download, and it will download all the packages for me for working of the NLTK. Alright guys, in this part we're going to talk about tokenization. So first of all, what is tokenization? Now tokenization is the process of splitting text into smaller parts, and every smaller parts are called tokens, and it's one of the most important steps in natural language processing, or NLP. So there are two levels of tokenization. We have sentence level tokenization and also word level tokenization. Now in sentence level tokenization, we are going to split a text into smaller sentences, and in word tokenization we are going to split sentences into words. Now let's just create our coding and tokenization. Okay, we're going to start our examples from sentence tokenization. I've opened my Jupyter notebook. Now the first thing we need to import sent tokenize from nltk.tokenize. Because using sent tokenize, we can tokenize our sentences. So we're going to just say from nltk.tokenize, we are going to import sent tokenize. So after importing our sent tokenize, now we are going to create our text. I'm going to just create a simple text in here, and hello friends, welcome to codeloop.org, like the article. So you can get the source codes from codeloop.org, my blog. Okay, now after creating of your text, now we need to tokenize this sentence using sent tokenize. So we can just say sent tokenize, and we need to add our text in here. So now let me just run this, and you can see that we have hello friends, we have welcome to codeloop.org, and we have like the article. Now you can see or we can say you can see that how easily we have splitted our this text into sentences. Now this sent tokenize function uses an instance of punct sentence tokenizer. Now if you see the documentation of NLTK for punct sentence tokenizer, now this tokenizer divides the text into a list of sentences by using an unsupervised algorithm to build a model for abbreviation words, collocations, and words that start sentences. Now you can see it must be trained on large collection of plain text in a target language before it can be used. So now also you can see that the NLTK data package includes a pre-trained punct tokenizer for English. I think it's not just for English. There are I think there are around 22 languages that you can use. Now these are the pre-trained tokenizers. So now let's just create our example in punct sentence tokenizer. Okay, now the first thing we are going to just import NLTK, and after importing NLTK, we need to load punct sentence tokenizer with the language that we want. For example, I want English language, so I'm going to just say tokenizer and NLTK data load, and in here you need to just specify the language. Now if you see documentation, let me just bring it in here, and you can just we are using English pickle, and you can add this in here like this. So after this, now we need to create our text. I'm going to just create my text, and this is the text, hello friends, or we are going to just use we have a text in here, so this is my text, we are going to use this in here. Okay, now we can just simply say tokenizer dot tokenize, and in here you need to add your text. So it is my text. Now let me just run this. Now you can see that using punct sentence tokenizer and English pickle, we have splitted our text into small sentences. Also you can tokenize from different language using different pickle file other than English. So I have said that There are different languages that you can use. In here we have just used English, but you can change this to for example another language. So for this, the first thing I need, so let me just copy this in here, and let me change this to Spanish tokenizer. And in here, instead of English, we need to add Spanish because we are going to use Spanish tokenizer. So it's a pre-trained model that's used for tokenization. Okay, after this we need to just create our text. So now let me just copy Spanish text. After this we can say that Spanish tokenizer, so let me just copy this, dot tokenize, and we are going to tokenize my text that is in Spanish language. Now you can see that we have successfully tokenized the Spanish text into sentences. So like this you can work with sentence tokenizer in NLTK. Okay, now let's just use a file, a txt file from Gutenberg corpus, and tokenize that. So now I've already imported send tokenize, and after that we are going to just say from nltk.corpus we are going to import Gutenberg like this. Now there will be a question in your mind that what is corpus. Now if you see the documentation for the NLTK, the nltk.corpus package defines a collection of corpus reader classes which can be used to access the contents of a diverse set of corpora. Now the list of available corpora is given in here. Now if you see in here, there are different contents that you can use. So snowball, data, porter, steamer, and okay guys, now let's just use a txt file from Gutenberg corpus. Now the first thing we need, we are going to just import that. So from nltk.corpus we are going to import Gutenberg, and there will be a question in your mind that what's corpus. If you see the documentation of NLTK, the nltk.corpus package defines a collection of corpus reader classes which can be used to access the contents of a diverse of corpora. Now the list of available corpora is given in here, and if you see that there are different corpora that's available, and you can use it. Now make sure that you have downloaded this. So now after this we are going to just use Shakespeare.txt. So for this I'm going to just say my text Gutenberg, and in here so Gutenberg.row, and in here we need to just add this file name, and now we can tokenize this, and we can just use send tokenize, and in here we need to just add our my text. So first let me just print the my text, or we can just say my text. Now you can see that this is the text from Gutenberg corpus, and now let me just remove this, and now this time I'm going to just tokenize this text. So now you can see that this is tokenized. This is the first sentence, second sentence, and like this we have tokenized this txt file. Okay guys, now let's just create our word tokenization example. Now we can do word tokenization using word tokenize function. The word tokenize function uses an instance of NLTK that's called tree bank word tokenizer. Now there are different ways that you can do tokenization on words. For example, we have word tokenize, we have regXP tokenizer. Even you can use a split method of Python itself for tokenizing. Now let me just show you the example. So first of all, I'm going to just create a text in here. I'm going to just say my text, and I'm going to say hello world. Welcome to Python natural language processing course for you. So now we will use this for. Okay, after creating our text, the simplest tokenizer that is related to Python, it's the split method for the split method of the Python string. Now this is the most basic tokenizer, and it's not related to NLTK package. It is just related to Python. So for example, we can just say my text dot split, and now if I run this, you can see that we have hello world, welcome to Python natural language course for you. And also you can use word tokenize. Now this is the most commonly used tokenizer in NLTK. Basically we can say that it's the default one. And first we need to just import this from NLTK.tokenize. We are going to import word tokenize, and after importing, so you can see using this word tokenize function we can do our tokenization. We can just say word tokenize, and we need to add our my text in here. Now let me just run this, and you can see that we have hello world, welcome, and these are the words. So also there are different tokenizers. I have said that you can use, for example, regXP tokenize, wordpank tokenize, and also blank line tokenize. So now let's just take a look at regXP tokenize. Now most of the other tokenizers can be derived from this tokenizer. Also you can build a very specific tokenizer using a different pattern with regXP tokenizer. So the first thing we need to import this tokenizer. So from nltk.tokenize we are going to import this tokenizer. And after importing this, we have already created our text. Now we need to just bring some, let me just add an @ symbol in here. Welcome, let me just add 2 in here like this. Okay, so now first let me just write my patterns, and after that I will describe that what it means. Now we can just say print, or because I'm using PyCharm ID, so all time I'm going to just use print. So you can just say regXP. Let me just copy this. So dot tokenize, and the first thing we need to add our text in here, and after that we need to just add our pattern in here. You need to specify that what pattern you want to use. So first let me just use this pattern. Now this pattern means that we have used this as a regular expression pattern, which means that we need all the words and digits from the string. So we want all the words and digits from the strings. For example, and other symbols can be used as a splitter. For example, we want hello world to all of them. Now if you run this, invalid syntax pattern, oh guys, we have forgot to add the sign, equal sign in here. Now let me just run it again. Object has no attribute tokenize, and we don't need this tokenize in here. We can use this directly, and now you can see that we have our hello world. You can see that there's no symbols in here, and if you see in this hello world in here, we have two symbols, but we don't have these symbols, just we have the 2 and also 4 in here. Okay, now let's add another pattern in here, and let me just copy this, and this time I'm going to use another pattern. So there are different patterns. Now in here we are specifying this pattern, and it means that the result will produce only the digits from the string. For example, if I run this, I will just tokenize this 2 and 4 because we have specified in the pattern that we are tokenizing just the digits. And now let me just run this, and you can see that we are receiving 2 and 4 in here. So like this you can work with the word tokenization in NLTK. In this part we're going to talk about stemming. So first of all, what is stemming? Now stemming is a process to remove affixes from a word ending up with the stem, or in literal term you can say that stemming is the process of cutting down the branches to its stem. So using a stem we can cut down a word or token to its stem or base word. For example, the word eat will have variations like eating, eating, eats, or we can say the word like will be liking, likely, or liked. Now stemming is most commonly used by search engines for indexing words. Instead of storing all forms of a word, a search engine can store only the stem. Now there are different stemmers that you can use in NLTK. For example, we have Porter stemmer, we have Lancaster stemmer, we have Snowball stemmer. Now let's just create some examples on the stemming. Okay, now let's just start from Porter stemmer, and it is the default stemmer in NLTK. We're going to just use from nltk.stem, so it is related to this nltk.stem package, and we are going to import Porter stemmer. So now after importing of Porter stemmer, now we need to just create the object of Porter stemmer. So we can just say Porter stemmer, and we can just use this Porter stemmer. And now we can do stemming on our words. Now you can just say Porter stemmer dot stem, and in here, for example, drinking, and now if I run this, you can see that drinking became drink. And for example, if you say eating, so now you can see now it's eat. So this was Porter stemmer, and this was the simplest stemmer. Also we have Lancaster stemmer. Now Lancaster stemmer is just like the Porter stemmer, but it's known to be slightly more aggressive than the Porter stemmer. Now let me just create the example. The first thing we need to import, so let me just copy this, and this time I'm going to just use Lancaster steamer. And now we need to just create the object of Lancaster steamer, so like this. And now we can do our steaming, and we can just say Lancaster steamer dot steam. For example, let's just use, for example, drinks. You can see it's drink. If I use eating in here, it's eat. Drinking, drink. Now if I use likely, I will receive the result like or not. Yeah, you can see it's doing like this. Now there's another steamer, and that's called snowball steamer. Now the best thing about snowball steamer is this, that it supports, I think, about 13 languages. And now there are different languages that you can use. So now let me just show you the example. So first we need to, from nltk.steam, we need to just import snowball steamer. So snowball steamer, snowball steamer. So I think it is like this. So we have import in here and make the snowball steamer. Let me just run this. Okay, now after this we need to just create the object of our this snowball. First let me just show you the languages that are available in snowball steamer. So we can just say snowball steamer dot languages. And you can see that these are the languages that we have: Arabic, English, Finnish, French, German. There are different languages that supports Russian, Spanish, Swedish. Now, so let me just create the object of snow steamer. So snowball steamer. So after creating of the snowball steamer, you need to specify the language. So for example, English. And after this we can just say snow steamer dot steam, and for example I'm going to just say eating. And now if I run this, you can see it's eat. And if I say drinking, so it's drink. Now let's just check likely with this. So now you can see we have received the best result using the snow steamer. Now if you see in here where we have used the Lancaster steamer, you can see that this is like, and but using the Porter steamer we have received the best result. In this part we are going to talk about lemmatization. So what is lemmatization? Lemmatization process is the same as a steaming process, but it brings context to the words. So it links words with similar meaning to one word. And unlike steaming, you are always left with a valid word that means the same thing. However, the word you end up with can be completely different. So now let's just create an example and you will know that what I mean. Okay, so the first thing we need to import WordNet Lemmatizer from nltk.steam. So we are going to say from nltk.steam import WordNet Lemmatizer. Now, after importing of WordNet Lemmatizer, we need to create the object of this Lemmatizer. So Lemmatizer, and we are going to just say WordNet Lemmatizer. Now we can do lemmatization on our words. We can just say lemmatizer dot lemmatize, and in here I'm going to just say eating. Now let me just run this. So lematizer, oh, this is not lematizer, this is lematize, and you can see that we are receiving eating. And now this time if I change, if I give pause to verb, and you can see that we will receive eat. Now let me just run this. You can see that we are receiving eat. Now let me just use another word. This time I'm going to just use, for example, better, and the pause I'm going to just give it adjective. Now if I run this, you can see that we are receiving a different word. It's good. We have better and we have good. Now let's just see the difference between the lemmatization and also steaming. So first I'm going to, from nltk.steam, import porter steamer, and after importing of porter steamer, we need to just create the object of our porter steamer. Okay, now first we are going to use the steamer. We are going to say steamer.steam, and in here we need to add our word. I'm going to just say use believes, and now let me just run this. You can see that we are receiving believe and we are not receiving yes. And if I use lemmatizer, let me just copy this. Lemmatizer.lemmatize, and I need to use this word. Now you can see that in this example the porter steamer just removes the es from the word, but the lemmatizer found the valid root of the word, that's believe. So like this you can work with the lemmatization in NLTK. In this part we're going to talk about stop words. So what are stop words? Stop words are words that generally do not contribute to the meaning of a sentence. For example, stop words are like da, and, in, for, that a search engine has been programmed to ignore when indexing entries for searching and when retrieving them as the result of a search query. Now, for the purposes of information retrieval and natural language processing, NLTK comes with a pre-built list of stop words for about 22 languages. We will check that. Now let's just create our example on stop words. Okay, so first of all, from nltk.corpus we are going to import stop words, and also from nltk.tokenize we are going to import word tokenize. So after importing of stop words and word tokenize, now let me just configure the language. We can just say stop words, and we can just say stop words dot words, and let me just use English in here. And if I say stop words, so you can see that these are the stop words in English. You can see it's a big list: I, me, myself, we, you, she, she is, himself, her, and it, them, what, which, who. Now these are the stop words that are available in English language, and you can see this is the complete list. So now let's just check that the language that are available for the stop words, and in here we can just say stop words dot file IDs, and you can see that these are the list of language that I think it's about 22 languages that are available for stop words. These are the pre-built stop words in these languages. Okay, now let's just create our text. I'm going to just say my text, and in here I want to say this is my first example in NLTK for you, or we can say stop words for you, NLTK stop words for you. And now after this we need to just create our language, so we can just say stop words, and we need to just say stop words dot words, and I'm going to just use English. After doing this, now we can say, let me just create a words, and the first thing we need to tokenize our this text, and we are going to just use word tokenize. Add the text in here, my text, and if you see the words, you can see that this is tokenized to the words. This is my first example. Now after tokenization, let me just create my filtered. Now in this example, if you see, this is these are stop words. Example is not stop word, N is a stop word, NLTK is not stop word, for is a stop word, U is a stop word, and I think this first is also not stop word, so we'll check this. Now first I'm going to just create a list, an empty list in here. I'm going to just call it filtered list, and after creating of the list, now we are going to just iterate over the stop words, so we can just say for word in words, if word not in stop words, so if this is the case, we are going to just say filtered list. We want to append our this word in this list, so append, and we are going to just add our word in here. And now, so first let me just, okay, now if I say filtered list in here, so now you can see that first example NLTK stop words. Now these are not stop words, as I've already said, but this is my N for you. These are the stop words. So also you can see the frequency distribution for the words. I will talk about the frequency distribution in the later part, but using frequency distribution you can find that how many words is used in here. For example, in here, let me just, in this section, first we need to just import this from nltk.pro probability import freqdist, nltk.probability. Let me just check this. Okay, this is probability. Okay, now after importing of frequency distribution, now we need to just say freqdist, and in here you need to add your filtered list like this. And now you can print this, so you can see that First, this is one times, examples one time, NLTK is one time, and let me just use another NLTK. So I can say NLTK is good. Now you can see in here the word NLTK we have in here, and also we have in here, so 2 times we have NLTK. So I'm going to run from here because okay, now in here if I run this again, so now you can see the frequency distribution. NLTK is 2 times, first is 1 time, example 1, word 1. Also you can plot this. You can just say dot plot. So now you can see that our NLTK is 2 times, and these are the first examples, and good. So we'll talk about the frequency distribution more in the later parts. Alright guys, in this part we're going to talk about frequency distribution. So using frequency distribution we can find that how many times a word is used in a text or sentence, or we can count words in our text using frequency distribution. So now let's just create our example. So frequency distribution is related to NLTK.probability. First we need to import that from NLTK.probability. So from this class we are going to just import freq test. Also we are going to use from NLTK.book, we are going to import text1 like this. Let me just run this. Okay, now you can see that it's loading the text for us from this NLTK.book. It's loading text1. Now after this, now we are going to just create a frequency distribution in here. So freq like this, and let's just add our text1 in here. And now if I say freq test, so now we can see that this is the result, and you can see that the mostly used are stop words. Now you can see now these are the frequency distribution. This is for off and like this. So when you are going to do frequency distribution, you need to remove these stop words. We will do this in the later parts. Now if you want to see how many, for example, book are in the text, for this we can just say freq distribution, and in here we need to add book. Now you can see that the book is 4 times. Now it means that we have 4 times book in our this text1. Now let's just create our own text, and here I'm going to just say hello friends, this is our text, and this text is related to frequency distribution. Okay, now after creating of our this text, now we are going to tokenize this. We need to from NLTK.tokenize, we are going to import word tokenize. Okay, now after this we are going to just create a text underscore for let me just call it text talk, and we need to just use this word tokenize. Add your text in here. Now if you if you see this text talk, you can see that this is our tokenized words. Now after this we are going to just create frequency distribution, and we're going to just call it fric dist, and in here you need to add this text token here. And now if you fric dist is we are okay. Now if you see fric dist, you can see that this is the distribution. This is 2 times, as is 2 times, text is 2 times, hello is 1 times, and related is 1 time. So now also, for example, if you want to see that for the text, you can also say fric dist, and I want to just write text in here, and you can see that we are receiving 2 in here. Okay, now let's just create another example. This time we're going to use Gutenberg from nltk.corpus. The first thing you need from nltk.corpus, we are going to import Gutenberg. And after this we need to load .txt file from this Gutenberg. There are different files, but we are going to use the Shakespeare file, and you can just say Gutenberg.raw, and in here we are going to add our file name. So this is the file name. So after loading the file, now we need to tokenize this. I'm going to just create word toke and word tokenize. We need to add the text in here, and now if you see the word toke, so word toke, you can see that we have now you can see that this is the file, and now if you want to, for example, I want the 20 words, and now you can see that these are the 20 words. Now we're going to create our frequency distribution in here. I'm going to just say fric dist, so fric dist, and in here we need to just add our this word toke. Now if you see this fric dist, now you can see that this is the frequency distribution of the words. Also you can say fric dist dot most common, and I'm going to just print the 20 words. So now you can see that these are the most commons. Also you can plot the frequency distribution. You can just say fric dist dot plot, and for example 15, and now you can see that this is the frequency distribution for the words. Now the mostly common words is da, and this is the frequency distribution around 3000. I think it's 2000. Now this is the da. Okay, now like this you can use frequency distribution in NLTK. Alright guys, in this part we're going to talk about WordNet and Synset. So WordNet is a dictionary or lexical database for English language, and it's mostly used for natural language processing or NLP. And Synset is used for searching of the words in the WordNet. Some of the words may have only one synset, and some of the words may have several synsets. Now let's just check the documentation for NLTK. Okay, now you can see the WordNet interface. WordNet is just another NLTK corpus reader and can be imported like this. From nltk.corpus import WordNet, and for more compact code, it's telling that we recommend from nltk.corpus import WordNet as WN. And also we can look up a word using synsets. This function as an optional parts of speech argument, which lets you constrain the parts of speech of the word. Now let's just create our example. So the first thing we need to import from nltk.corpus. We are going to just import WordNet as WN. So after importing this, now I'm going to just use a word, for example, hello world. I'm going to just say WN hello, and we can just say WN dot synsets, and we're going to write hello. Now if I see this WN hello, you can see that for this we have just one synset. And now you can find the definition of this synset. You can just say WN hello dot definition. Oh sorry, okay, so let me just remove this. Okay, so this was the synset for this. Now we are going to just say hello and WN dot synset, and we are going to add this version of hello in here like this. And now we can find the definition. So hello dot definition. So you can see that this is the definition. It's an expression of greeting. Also you can find the name. You can just say hello dot name. So this is the name. Also you can find an example for this. So we can just say hello dot examples, and you can see that this is the example that we have received for this. Let's just use another word. Let me just use WN clear and WN dot synsets, and we are going to just use clear. Now if you see this in this example there was just one synset, and if we check this clear WN clear, you can see that we have a bunch of synsets for this. You can see that they're different, clear, different versions. So this is the name, this is the parts of speech tagging, and this is like a version number that we have for this. And for example, I want to just use this for example this clear, and in here I'm going to just say clear 07 WN dot synset, and we need to add this in here. So now you can see that this is, now you can find the dot definition. This is the definition. You can find the for example the name, sorry, this is the name. So this is the name. Also you can find, for example, the examples. So examples, and then you can see that this is the example. Also you can use a range. For example, I want to find the definition from 0 up to 7 of clear versions. You can do, let me just show you in here, for I in range 0 up to 7, clear, W in clear, and pass I in here. Now we can find clear dot name, we can find clear dot definition, and also you can say clear dot examples. Okay, now let me just use print in here. So print, because we are in the for loop, print, and now let me just run this. So now you can see that so this is the name, this is the definition, and this is an example. This is the name, this is the definition, and also the example. So like this you can work with the WordNet and Synset. So we have saw that how you can work with WordNet and Synset. In this part we're going to learn about finding antonyms. Now so the first thing we need to import, so from nltk.corpus import WordNet. And after that we are going to just create an empty list. So now we are going to just say for syn in WordNet.Synsets. For example, we are going to just find antonyms for the bad. For L in syn.lemmas. Now we are going to check that if our L or lemmas is in the antonyms onto names, we are going to just append that to our this antonyms list. So antonyms dot append L dot antonyms, and we are going to just use the first index dot name, and we are going to print the name. So now let's just use our antonyms in here. You can see that for the bad we have good, goodness, good, and regretful. Now if I change this to, for example, better, what I will receive. Now for that I'm receiving good, 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 L badly. Let's just use another word, for example, like. And you can see that we are receiving worse and worse, bad, evil, L badly. So like this you can find antonyms in the WordNet. In this part we're going to talk about parts of speech tagging. So first of all, what is parts of speech? Now parts of speech, or POS, is one of the many tasks in natural language processing. You may have heard about parts of speech. So in English the main parts of speech are noun, pronoun, adjective, verb, adverb, preposition, and so on. Before this you'll be familiar that what are adjectives or what are adverbs and what are the difference between these. Now as a human you will know about this. But let's think about the system where we can encode all this knowledge. Now the parts of speech tag identifies whether a word is noun, verb, or adjective, and so on. There are numerous applications of parts of speech tagging that you can use. For example, information retrieval, machine translation, and so on. So now, what's parts of speech tagging? So parts of speech tagging is the process of assigning a category, for example, noun, verb, adjective, and so on, tags to individual tokens in a sentence. Now in NLTK, taggers are present in the nltk.tag package, and it is inherited by the tagger I base class. Now let's just create our practical example in parts of speech tagging. So the first thing we need to import. So first I'm going to import from nltk.tokenize. I'm going to import word tokenize, and now I need to import pose tag or POS tag from NLTK. So from NLTK import POS tag. Okay, now let me just run this. Now after this we are going to just create a text. Also I'm going to tokenize this directly. So word tokenize, for example, I'm going to just say Python is a good language. Okay, now we can use pose tag or POS tag, and I'm going to just add my text in here. Now if I run this, now you can see that Python is NN, it's I think noun, is VB, is DT, this is for good, and this is for language. Now in the first you will not be familiar with these tags, but there is a function that you can use. So the function name is help, and using this help function we can know about these tags. So for example, let me just show you. We can just say help dot app in underscore tag set, and in here you need to specify the tag. For example, I want to copy this. So now if I run this, help dot up in tag, let me just check this. Okay guys, I think the problem is not with this function. The problem is that we have imported in here. Now we need to run this. Let me just run it again. Yeah, now the problem was with that. Now you can see that N is noun, common, singular, or mass. Now also there is an example for this. You can see that we have this example. Now let me just change this to this. What's the meaning of this? And if I run this, you can see that it's verb, it's present tense, and it's third person singular, and you can see that we have an example for this. And let's check this DT. And let me run this. You can see it's determiner, and this is the example. Now this is a very good function that you can use, and you can know about the tags, different tags. Now let's just create another example. So for this, the first thing we are going to use Wikipedia library. So first you need to install that. You can just simply use pip install Wikipedia, and it will be installed. Now after installation we need to import Wikipedia. I'm going to just say import Wikipedia. After import, now I'm going to just create a grammar in here, and I want to just extract the summary of the grammar from the Wikipedia. Now I have a complete video on using this Wikipedia library. You can just check my YouTube videos and you will find this the usage of the Wikipedia library. Now I'm going to just use grammar in here. Now if you we have error. Okay, it's because I think I have internet connection problem. Now we can run this again. So let me just grammar. So now you can see that this is the summary of the grammar from the Wikipedia, and now we need to tokenize this. I'm going to just say token, and we can use word tokenize, and in here we need to add our this grammar. And if you see gram token, you can see that this is split it into words like this. You can see we have our words. Now after doing this, now we are going to do post tagging or POS tagging. So I'm going to just say simple POS and POS underscore tag, and in here we can add our grammar token, so like this. Now we can check the result. Okay, now you can see that we have successfully tagged these words. You can see this IN, NNS. Now let's just check some of them using the helper function. Let me just copy from here. Okay, now I want to just check this VBG. So now you can see it's verb present, and let me check this NNS. So, or we can say this IN. I think it's interjection. Yeah, it's preposition or conjunction subordinating, and let's just use this NNP. And you can see that this is noun, proper, and also singular. So now let's just extract for example, I want to extract this NNP, noun, proper, singular, and also NN from this grammar text. Now for this we are going to just first create all noun, and let me just say word for word, POS in sample POS, and now we are going to check that if POS and in here you can add the tag name, so NN, also NNP. And now if you check the all noun, so you can see that these are the all NN and also NNP. Grammar, ancient, Greek, set, composition, language, term, and phonology, morphology, syntax. Now these are related to NN and also NNP tags. So we have saw POS tagging. Now we are going to talk about named entity recognition, or NER. So one of the most problems in the text labeling is finding the entities. For example, finding the name of locations, the name of organizations, or the name of person. So for this we can call it named entity recognition, or NER. Now there are two ways of named entity recognition in NLTK. The first way is that you can use pre-trained named entity recognition. And the second way is that you can build a machine learning based model. From NLTK we can use NE-chunk method for these kind of functionalities. And also there is a wrapper around Stanford named entity recognition tagger. So now let's just create our example in ER. So first we need some imports. The first thing we are going to just import NLTK. After NLTK, I have already said that in NLTK you can use NE-chunk method. So now we are going to import NE-chunk. Also we are going to just import post tag. The last thing that we need is word tokenize. So from NLTK.tokenize we are going to import word tokenize. Now these are the imports that we are going to use, but we have okay, so from NLTK.tag import post tag. So these are the imports that we are going to use. Now we are going to create our text. So this is a simple text. His name is John. John is studying at Stanford University in California. Okay, now after this, now we are going to use chunk. So NE-chunk. So let me just print this. So print NE-chunk. And now also we need to do POS tagging. So and after that you need to tokenize also. So you're going to use word tokenize and add your text in here. Also I'm going to make the binary to false. Now and here we have used the binary to false. If we set the binary to true, then it provides the output for the entire sentence. Now let me just run this. So now you can see that we have received our, so this is preposition, this is a noun, and this is, you can see that John is person. Again we have two John, and this is also person. Is verb, studying is verb, and now you can see that Stanford and university is organizations. And also GPE, the California is GPE, geopolitical entity. So like this you can work. Let me just remove this binary, and so we're going to run it again. So you can see that we are receiving the same result. So like this you can work with the named entity recognition. Also I have said that you can use Stanford named entity recognizer, or NER. So Stanford in ER is a Java implementation of a named entity recognizer. Named entity recognition in ER labels sequences of words in a text which are the names of things such as person and company names, or gene and protein names. So also you can use this for working with NER. In this part we're going to talk about default tagger and unigram tagger. So default tagging provides a baseline for parts of speech tagging, and it's performed using the default tagger class. And it simply assigns the same parts of speech tag to every token. Now the default tagger class takes tag as a single argument. For example, NN is the tag for a singular noun. On the other hand, a unigram tagger, now a unigram generally refers to a single token, So a unigram tagger only uses a single word as its context for determining the parts of speech tag. Now let's just create some examples of these. So the first thing we are going to just from NLTK dot tag, we are going to import default tagger, and after importing the default tagger, now we are going to just create our tagger, so our default tagger in here, and in here, for example, I want to use NN. And after this, now we can do our tagging process. So we can just say tagger dot tag, and for example, hello and world. So you can see that this is the result, and let me just copy this once more. For example, good morning. Now you can see that this is the result. So now in here, for every tagger we have a tag method. This is the tag method, which takes tokens as a list of argument. For example, in here we have used 2-word token, good morning or hello world. Also you can untag a sentence. So the first thing we need from NLTK dot tag, we are going to import untag. And let me run this, and after that we are going to just say untag. So now the first one is, for example, hello, and the tag is NN. We have world, and the tag is NN. Now if I run this, you can see now it's untagged. Also, there is a function in default tagger that you can predict the accuracy. So for this, we're going to use brown corpus. The brown corpus was the first million-word electronic corpus of English that was created in 1961 at Brown University. This corpus contains text from 500 sources, and the sources have been categorized by genres such as news, editorial, and so on. Now the first thing we need to import this. So from NLTK dot corpus, we are going to import brown, and after importing this, also we need from NLTK dot tag, we are going to import, or we have already imported the default tagger and we don't need to import it again. Okay, now after this we are going to just create our brown tagged. So I'm going to just say brown tagged sentence, and this is brown dot tagged sent, and in here you need to specify the categories. So for example, I'm going to use news category in here like this. Now after this, you can do use your default tagger. So let me just create default tagger, for example NN, and now we can do our tagging. So now we can see the accuracy. So dot evaluate. So this is the function, and in here we can pass our this brown tagged sentence in here. Okay, now let me just run this. So you can see that we have received a poorly result, and it's about 30% accuracy. Now there's another tagger that I've already talked about, that's unigram tagger. Now let's just create the example of that. So in here I'm going to use tree-bound corpus. So first of all, we are going to just say from NLTK dot tag I'm going to import unigram tagger. Also I need to, from nltk.corpus, I'm going to import 3bank corpus. Now let me just run this. Okay. After this, we're going to just create a train sense, and we are going to just say 3bank dot tagged sense, and we are going to just get the 2000 sentences. And after that, we're going to create our unigram tagger. So unigram tagger, and we need to pass our train sentence in here. Now you can just say 3bank dot sense, and we are going to just print this 0 index. So let me just run this, and you can see that this is the result for the 0. And now we are going to just do our tagging on this. So tagger dot tag, so okay, tagger dot tag, and now let me just copy this and add this in here. Now run this. You can see that we have tagged these words with for example NNP, CD, NNS, VB, so it's verb. Now let's just check the accuracy. So in here we have just used it 2000 tagged sentences from the 3bank corpus as a training set to initialize the unigram tagger class. Now for the testing of the accuracy, we are going to just create a test sent, and this time we are going to dot tagged, and we are going to use now after 2000 sentence for the training, and now we can check the accuracy. So tagger dot evaluate, and we need to pass this test sentence in here. Okay, now you can see that we have received a good result in here, and it is about 82%. So like this, you can work with unigram tagger and also default tagging. Alright guys, in this part we're going to talk about back-off tagging. Now, back-off tagging is one of the features from sequential back-off tagger. Using back-off tagging, we can chain taggers together. So if that one tagger does not know how to tag a word, it passes the word to the next back-off tagger. If that one was not able to tag the word, it can pass that to the another back-off tagger. Now, this is the work for back-off tagging, and it will increase the accuracy also. Now let's just create an example of back-off tagging. Okay, now so this is the previous example that we have used unigram tagger, and we have received 82% accuracy. Now we are going to just create our back-off tagging in here. So I'm going to just first create tagger 1 in here, and this is for default tagger. Also we're going to create tagger 2, and this is unigram tagger. We are going to add our train sentence in here, and also now we need to just use backoff in here, and for the backoff I'm going to use tagger 1. Now it means that if this unigram tagger was not able to tag the word, it will pass that to this tagger 1. Now this time if we print the accuracy, now let me just say tagger 2 dot evaluate, and we are going to just pass the test sentence in here. So now you can see that the accuracy is around 96%. So like this, you can work backoff tagging. Along with unigram tagger, there are two more taggers that you can use. For example, we have bigram tagger and also trigram tagger. In this part, we're going to learn that how you can use enchant module. So enchant is a module in Python which is used to check the spelling of a word. Gives suggestion to correct words, also gives antonyms and synonyms of the words. Also, using enchant module, you can tokenize a sentence to the words. Now let's just see the examples. Now the first thing you need to install this library because it's not a part of NLTK. You need to just say pip install PyEnchant like this, and it will be installed. Now the first thing we need to just import enchant, and now we need to just first create our dictionary. So let me just call it dictionary, and in here we are going to .dict. We're going to use English, so ENUS. And after that, we are going to just get a word from the user. So please enter your word. And now we can just say print dictionary.check word. And so now let me just first run this. Let me just okay, so if I say, for example, like, now you can see it's true because like is a word. And if I say like this, now you can see it's false because it's not a correct word. Now you can receive suggestion. You can just in here print dictionary.suggest, and we are going to just add the word in here. Now let me just run it again. Okay, now in here let me just say, for example, if I write, now you can see that it's true. And let me just run this again. Now if I say like this, you can see that also I'm receiving some suggestions. It's saying it's false, but I'm receiving like or lie link like this suggestions. Also you can there's a tokenizer for enchant that you can use. Now let me just show you. So for this, the first thing you need to from enchant.tokenize import get tokenizer. So the first thing we need to just create our text in here, and I'm going to just say hello world, welcome to NLP tutorial, and please subscribe my channel. Now the first thing we need to just create our tokenizer class, and we need to get the tokenizer, and it is English US. Let me just create a list, an empty list. Now we can just say for word and tokenizer text. Now we can append the tokens to the list, so .append word, and we can just print the words. Print token list. Now let me just run this. So you can see that this is our tokenizer. let's token our word, our sentence tokened. So like this you can work with the enchant library. In this video we're going to learn that what are bigrams. Now bigrams are two consecutive words that occur in a text. A bigram is a sequence of two adjacent elements from a string or tokens, which are typically letters or words. For example, like rainbow, John Doe, heavy rain. So these are bigrams, two consecutive words. Now let's just create our example. Okay, the first thing we need from nltk.corpus, we are going to import web text, also stop words. After this, we are going to, from nltk, we are going to import bigrams. Also, we are going to use frequency distribution. So from nltk.probability import freq dist. So after importing our libraries, now I'm going to use web text corpus, and there's a text at name of grail.txt. I'm going to use the data from that. So text data web text.words, and the text name is grail.txt. So it is so this grail.txt is belong to this web text. So after that we are going to just create our stop words. So stop words dot words, and we are going to use English. So let me just make this stop words. So after this we need to create a list, because we want to append all our words and data to the list. So this list is this is an empty list, and I'm going to just call it filtered list. So after this I'm going to just search in our text data, so for word and text data, and after that I'm going to check for the stop words. I want to say that if word not in stop words, so stop words, okay. Now after doing this, also I need to check the length of the word, and here I want the length of the word should be above 3 length. So I'm going to just say if len word, so it should be greater than 3. And now I can append my data to this filtered list. Dot append, and I'm going to just say word. Now after this we are going to create our bigram, so we can just say bigram, bigrams, and in here you need to add this filtered list. So if you see the bigrams, now your bigram, let me just, so this is the bigram object, and now after this we are going to just create our frequency distribution. And you need to pass bigram in here. Now you can check the most common and the frequency distribution. So most common, and we are going to use 10. So you can see now we have 2 words: black night, head night, club club, hello hello, French guard, mumble mumble, witch witch, burn burn, holy grail. So you can see that we have used the bigrams Now you can see that these are the two words that we have, two tokenized words that are consecutive occurred. Also, you can plot this, so you can just say frequency distribution dot plot, and so now you can see that this is the result. And also these are the most common words. 32 times we have black night, 29 times we have at night, and this is completely we have in our this graph. So like this you can work with the biograms. In this part we're going to talk about trigrams. So what are trigrams? Now, as the name suggests, trigrams are three consecutive words that occurred in a text. So now let's just create our example for trigram. So I've already imported my required libraries. So the first one is from nltk.corpus. I've imported web text, and also stop words. So from web text I will use grail.txt data. Also from NLTK I have imported trigrams. And also, because we are going to show the frequency distribution of words, from nltk.probability we are going to import frequency distribution. Now after importing of these libraries, we are going to just create our text data, and in here we are going to just say stop words dot words, and we are going to use English, and let me just make it set. So after creating of so we have stop words dot words, English name stop words is not defined, sorry, we have so this is stop words. Okay, after this I'm going to just create a filtered list because I want to add my words in the filtered list. So I'm going to just say filtered, or you can call it for filtered words or list, whatever you want, you can call it. And now we are going to just first iterate over the text data. So we are going to just say for word and text data. And after that we are going to check for the stop word. So if word not in stop words. After doing this we are going to check for the length of the word. So we are going to say that if we are going to just take the length of the word greater than 3. So if len word greater than 3, now we are going to just append our words to the filtered list, filtered words dot append, and we are going to add our word in here. So after this we need to create our trigram. So trigrams, and you need to add this in here. Okay, after this we are going to just create frequency distribution, fric test, and you need to add your trigram in here. Now you can find the most common words dot most common, and I want to print the 10 of them. So fric test. Oh, because we have forgot to load our data. Now we have in here we have our text data. Now we need to just so this is stop words, sorry, for this stop words, and in here we are going to just create our text data. and it is web text dot words grail dot txt. So we are going to just use this, and let me just check that I don't have any error in here. Stop words. Okay, now let me just run from the top. Run. Okay, now you can see that we are receiving trigrams. Hello, 3 consecutive words, and the frequency is 21, and sequick, and this is 15, and you can see that these are the 3 consecutive words that we are receiving from the grail.txt data. Also, you can plot this. You can just plot, and you can see that this is our plot for the frequency distribution. So like this you can work with the trigram. In this part we're going to talk about n-grams. So n-grams are n-words. It means that using n-grams you need to specify the number of words that you want. So for example, if you want 5, 6, you can just, after creating of n-grams, you need to specify that. Now let's just create our example. Okay, now these are our imports. First, I have used from nltk.corpus web text and also stop words, because I will use a text that's called singles.txt from web text. After that, I have imported from nltk import n-grams, and also because I want to show the frequency distribution of words. Now for that, from nltk.probability we are going to import freq_dist. After this we are going to just create our text data, and web text dot words, and in here you need to just use the name of the text. It is singles.txt. So after that we are going to just create our stop words in here. So stop words dot words, and we are going to just use English in here. Okay, after this we are going to just create an empty list. I'm going to just call it filtered words, because I want to append my words in this filtered words. Now we need to iterate over this text data. So I'm going to just say for word in text data, and now I'm going to check for the stop words. So if word not in stop words, also I'm going to check the length of the words. So if length word, and I'm going to choose my length of words should be greater than 3. Now I can append my words. So filtered words dot append the word. So after doing this we need to create our n-grams. So I'm going to just say n-grams, and you need to add your filtered words. Also now in here you need to specify, for example, I want the 6 words, and like this. So this is the number of words that we are searching. After doing this, n-grams, name n-grams is not defined, so we need to run this because okay. Now after doing this, also we're going to create our frequency distribution. So freq_dist and freq_dist. You can add your n-gram in here. Now we can print the most common words dot most common for example 20, and now you can see that we are receiving 6 words in here, so like this, 1 2 3 4 5 6, and this is the frequency distribution. Now if you change this to 5, for example, now you can see we have 5 words in here. So 1 2 3 4 5, and this is the frequency distribution. In here, this we have 2, we have 1 1 1, like this. Also you can plot, so fric this dot plot, for example 20, and you can see that this is the result of plot. So like this you can work with n-grams. So far we have learned a lot about NLTK library. Now you can do the same process using another library that's called TextBlob. Let's check their documentation about TextBlob. So if you see, TextBlob is a Python 2 and 3 library for processing textual data. It provides a simple API for diving into common natural language processing or NLP tasks, such as parts of speech tagging, noun phrase extraction, sentiment analysis, classification, translation, and many more. So you can see that they have the features of noun phrase extraction, parts of speech tagging, sentiment analysis, classification using naive Bayes and also decision tree, tokenization, word and phrase frequencies. So you can see that there are different features that you can use from TextBlob. Now let's just create some examples, and we are going to start from tokenization. So the first thing you need to install this. You can just use pip install TextBlob and it will be installed. After this, we need to just say from TextBlob we are going to import TextBlob. So after importing, now we are going to work on tokenization. So as we have already talked about tokenization and NLTK, so the tokenization is the process of dividing or splitting text or a sentence into a sequence of tokens. Now for example, I have a text in here, so TextBlob. So for example, hello friends, welcome to Python natural language processing. Now this is my text that I have created. So in TextBlob you can easily say that for example blob.words, so it's used for word tokenization. Now if I run this, you can see that this is a word list. I have hello friends, welcome to Python natural language processing, and our sentences split it into words. Also you can do blob.sentences, and now if I run this, you can see that we have 2 sentences in here. We have hello friends, and also we have welcome to Python natural language processing. So like this you can work with the tokenization in TextBlob. Also you can make a word singular or plural in TextBlob. So now I have already imported the TextBlob, and this is my text. So it's hello YouTubers, this is an NLP topic. Now you can see in here this is plural, and this is singular. Now if you want to make this plural singular, you can just do in TextBlob. So now let me just show you. We can just say text dot words, and the index is starting from 0, so this is 0 index and this is first index. I want to just make this singularize, so singularize. Right now it's plural YouTubers, but I want to make this singularize. Now you can see we are receiving YouTuber. Now in here you can see that we have topic, so we want to make it plural. You can just say text dot words. Now this is 0, 1, 2, 3, 4, 5, and the index is 5, and we can just say pluralize. And now if I run this, you can see that we are receiving topics. Now, so like this you can work with the text blob, singularize, and also pluralize. Okay, now let's just talk about the process of lemmatization in text blob. So I've imported a word from text blob. After this, now for example, I'm going to just create a word in here. So the word is octopi, and now I want to lemmatize this. So I can say just w dot lemmatize. And now you can see that we are receiving octopus. And let me just for example, let me just create another word in here. So word, and for example wind, and now I can just say w dot lemmatize. And now in here I want to lemmatize or get the verb of the word. So for this, for the POS or parts of speech, I'm going to just give it verb. Now let me just run this. Now you can see that I am receiving go in here. In this part, we're going to talk about spell correction in text blob, how you can do spell correction in a sentence using text blob. Now I've imported text blob from text blob, and now I'm going to just create in here a sentence. So text blob, for example, I'm going to just say I have good spelling, not good spelling. So you can see that there's have its misspelling, and also good is also misspelling. Now in using text blob you can make it correct. We can just say sense dot correct, and now if I run this, you can see I have good spelling, and how easily you so this is have and this is good. Okay, now let's just do noun phrase extraction. So I've imported text blob, and I've created a simple text, so you can get the source codes from the code loop website. Now how we can do the process of noun phrase extraction, we can just say for np in my text dot noun underscore phrases. Now we can just print np. Okay, now you can see that we are receiving source codes and also code loop website. Okay, now let's just do parts of speech tagging or POS tagging using text blob. So as we have already talked about parts of speech tagging, so it's the process of assigning a category, for example, noun, verb, adjective, and so on tags to individual tokens in a sentence. So I've already imported text blob, and this is my text, and I want to do POS tagging process on this text. So using text blob, so we can just say for words and tag in my text dot tags, and now we can just print words and also tag. Now let me just run this. Now you can see that U is proposition, this is MD, get is verb, this is determiner, source is noun, and this is I think singular noun. From in, I think in is interjection. code loop is noun and website is noun. So you can see that how easily we have done parts of speech tagging using text blob. Now let's talk about n-grams. So we have already saw n-grams in NLTK. N-grams is the combination of multiple words. So this is my important. Also I have this text. Now we can just do for n-gram in my text dot n-grams, and in here you want to specify the n-grams that you want. For example, I want it should be 2, and now I can just say print n-gram. Now let me just run this. So you can see that now we are receiving pair words like you can get the source codes from code loop website. Now if you change this to 3, and let me just run this, you can see that now we are receiving 3 words, you can get, and if you change this to 4, so you can see that we are receiving 4 words like this. So like this you can work with the n-grams in text blob. So now we're going to learn about sentiment analysis in text blob. So sentiment analysis is used as the process of determining the sentiments behind a character sequence. It may be used to determine whether the speaker or the person expressing the textual thoughts is in happy or sad mood, or it represents a neutral expression. The sentiment function of text blob returns two properties. So the first one is polarity, and the second one is subjectivity. So polarity value is between -1 and also 1. So 1 means positive and -1 means negative. And also subjectivity, it is the sentences generally refers to personal opinion, emotion, or judgment, and the value of subjectivity is between 0 and 1. Now let's just create an example. So I have imported text blob, and now I'm going to just create a text in here. So let me just call it, for example, sense and text blob. For example, I want to say I'm very happy today. Now we can just say sense.sentiment. Now let me just run this, and you can see that the polarity is 1. So 1 means that it is positive, and you can see that also the subjectivity is 1. Now if I change this that I'm not happy today, and if I run this, so now you can see that for the polarity we are receiving 0.4. It means that it is negative, and the subjectivity is 1. Now we're going to learn translation and also language detection using text blob. So I have imported the text blob, and this is my text, and this text is Turkish. Now first I want to detect the language, that what language are used in here. For this I can just say my text dot detect language. So we have received error because we need internet connection for this. Now let me just check my internet connection. Okay, now let me just run this again, and now you can see that it is TR. It means that it is a Turkish language. Now I want to translate this to English. For this I'm going to just say translated my text dot translate. So the first one is that from language. Now the language is TR, Turkish, and I want to translate this to English like this. Okay, now if you see the translated, Now you can see that it is subscribed to my channel. So like this you can work with the translation in text blob. In this part we're going to learn about text classification using text blob. So now you can see I have some data. So the first one is my training data. I have some sentences in here. Some of them are positive and some of them are negative, like this. So we have positive sentence in here and we have negative sentence in here. So this example is related to the documentation of text blob, and after that I have test data. So you can see that in here we have positive and also negative sentences. Now I have imported from text blob dot classifier. I have imported knife based classifier. So if you see documentation of text blob, you can see that we can do classification using knife based classifier, and also you can use decision tree. So we're using knife based classifier. Also I have imported text blob from text blob, and now let me just run this from the top. Okay, so after this we need to just create the object of our knife based classifier. So I'm going to just say C1 knife based classifier, and here we need to add our this training data, and we need to train our this data using knife based classifier. So after doing this, after training our data, now we can test this. We can just say c1 dot classify, and in here I need to just add a sentence in here. So for example, let me just write their sandwich so let me check the spelling of sandwich, like this. So their sandwich are amazing. Now let me just run this, and you can see that we are receiving a positive. And if I say c1 dot classify, for example, I don't like their pizza. So we have error. Sorry. Now let me just run this. So we have a dot in here. Now let me just run this, and you can see that it's negative. In the first we had this was so their sandwich are amazing. Now this is a positive, and in the second sentence you can see that I don't like their pizza, and in here we have received negative. Also you can check the accuracy, so we can just say c1 dot accuracy, and in here we can add our test data. So you can see that the accuracy is 83%. Another way to classify string of text is to use text blob objects. You can pass classifiers into the constructor of the text blob, and after that you can do text classification. Okay, now this is my example. I have created a text blob. The pizza was amazing, but the sandwich was horrible. I was not happy. And you can see I have said that you can pass the classifier into the constructor of the text blob, and in here we have classifier, and we need to add our classifier in here. So this is C1 is our knife based classifier. Now let me just run this. After that you can just say blob dot classify, and now you can see it is positive. So like this you can work with the text classification and text